This is Daniel Owens. He's the artificial intelligence team leader for the Army Evaluation Center. And he focuses on preparing his command to perform evaluations of AI-enabled systems and identifying ways AI can be used to improve test and evaluation processes. And he has a background in electrical engineering and information networking. All right, take it away, Daniel.
Thank you. With me is Vince Perry from the Army Research Lab, who has been instrumental in developing the Test Incident Report Analytics or Tyrannics tool. So today, we understand that we are the last presentation of the day, so I promise we won't go more than about an hour and a half. All right. So we'll begin to talk about some background information. What are test incident reports and how are they scored through ATEC? Test incident reports really are the bread and butter of the reliability evaluation for ATEC. And so the process that they go through is very well established, rigorous, and very important for the organization. And we'll talk about what Tyrannics itself is and how it is supposed to improve the process of scoring. Then I'll turn it over to Vince, who will look under the hood a bit more and how it works under the scenes and where we plan to go after this. So at every test event, most every test event, there are data collectors out in the field who are collecting events that happen during the testing. So this could be failures, it could be maintenance actions, it could be basic inventories, or anything of any significance is captured in a test incident report, whether it's a failure or not. It gets recorded in a common form, a standard form. There are variations on this form from system to system and test to test, but the basic structure and content is consistent across the board. And these TIRs are captured and they're uploaded into a database in ATEC. As they get uploaded, the evaluator from the Army Evaluation Center under ATEC has the chance to review all of them, and we'll review each of them and assign scores to them depending on their severity, their causality, their classification. At the same time that the evaluator is doing it, there's also a representative from the program manager and a user representative who are also doing the same thing. And often DOT&E will be going through them as well independently. Then all of these representatives will get together in a TIR scoring conference where we will discuss the TIRs, get further information as necessary, get any RFIs addressed, and come to a final consensus or as close to consensus as possible on the scoring of the TIRs, and ultimately they got bundled up into a report. Now, there could be, so these TIRs, there could be hundreds of them, there could potentially be thousands of them during a single test event. So this process can take a long time. So specifically what we're looking at is streamlining the process of the evaluator doing the pre-scoring for the TIRs. Test incident reports could cover absolutely anything, as I said, routine maintenance all the way up to catastrophic failures, and they contain a combination of structured and unstructured data. So structured data such as what system it was, when it happened, and who was involved with it. If there are particular subsystems that have been identified to be involved with it, maintenance actions and so forth. There are also unstructured fields, and especially the key one is a free text description of the incident. So typically these can be very detailed to the point of at 09:30:17 test player XYZ flipped this switch on and then off again. At 2 minutes later, this person did this, and this was the result. So they can be very detailed and very intricate. Sometimes, again, the quality of the TIRs can vary from test event to test event, depending on who's running it and the data collectors who capture it all. And then the evaluators score tests in 3 ways. They first have a class. They could be information TIRs, meaning they're just there for bookkeeping purposes. They can be minor, major, or critical. Those are fairly self-explanatory. Although the exact lines between what's considered minor, major, and critical can be can be a little bit fluid. There's a severity. It could be an essential function failure, system abort, rapidly recoverable event, and so forth. The exact definitions of these severities and what's considered to fall under each of them will vary system by system. And in fact, the names of these severities will also change. Some systems have, for instance, a crew correctable maintenance action, or an operational mission failure, or other definitions. And then there's chargeability. It could be caused by the hardware, it could be the software, it could be operator training, or a number of other things as well. And I said there are potentially hundreds to thousands of these per test event. So the process of getting the score correct and also consistent is very important. The other piece of background that helps in the scoring process is the document called the Failure Definition and Scoring Criteria. This is the guideline for how the TIRs should be scored. Again, these vary from system to system, but and the philosophy behind them seems to be changing in recent years. But historically, these have been very detailed, tens to hundreds of pages long, detailing down to if a particular subsystem is unavailable for 15 seconds or more, then it's this kind of failure. If it's unavailable for less than 15 seconds, it's that kind of failure. Very, very detailed, very, very in-depth. And so it can be very difficult to, particularly for a new evaluator coming in on a system, to have to dig through this FDSC to find the relevant pieces and parts of it in order to properly score the TIRs. But it is the guidebook, and it is the reference that the evaluators are expected to use for scoring the TIRs. So then, what is Tyrannics itself? As I mentioned, Tyrannics is designed to help the evaluator in the scoring process. After the test center produces the TIRs and uploads them to the database, and before going to the scoring conference. So the evaluator goes through each TIR on their own and gives them their score. In the process, we find many trends. For instance, we find repeated failures often. It's very common for particular failure modes to happen dozens of times during an event. Sometimes a failure mode will happen maybe only 2 or 3 times, but it's a significant one to care a lot about. And what we found is that it can be very time consuming for an evaluator to go through previous TIRs that maybe they've already scored, looking for that one TIR that they think is most similar to the one they're scoring right now, so that they can compare how they scored that one and see if the new one should be scored the same. So the first objective for Tyrannics is to speed that process up. This is just to provide a list of similar TIRs. So the evaluator opens up a TIR and asks the question, all right, find the last 5 TIRs maybe that are most similar to this so that I can compare how those were scored. The second capability that we are working toward in Tyrannics is identifying relevant sections within the FDSC. As I mentioned, this is the guidebook, and so if it's possible to pull up a paragraph from the FDSC that says this type of failure should be scored in this way, then that would be the goal. So taking comparing the free text from the TIR to the contents of the FDSC to find what from the FDSC seems to be most relevant to that TIR. And then the third one, I'm sorry, is there a question?
Yeah, Daniel, there's a question. Do you want it now or at the end?
I can take it now.
It says, are FDSCs standardized for types of systems and platforms since they're such vast documents?
So typically what happens is when a new program comes along, they will look at FDSCs from similar systems, do a lot of copy and paste, and then update what needs to be updated for the new system. Writing the FDSC is a time-consuming process. I understand. I've never been involved with it directly myself, but um, yeah. So typically they leverage previous systems significantly, but it's never completely standardized.
Thank you.
Okay. The third attribute, the third aspect of Tyrannics that we're working toward is having a score recommender. So to take the contents of the TIR and based on previous TIRs, recommend what most likely the score for this particular TIR should be. Understanding that this really is just a recommendation. TIRs are very nuanced and detailed, and a single word can substantially change the impact and the meaning of the event in the TIR. So this should be taken with a very large grain of salt, but at least it is a suggestion for where the evaluator should look. So that is the intent and purpose of Tyrannics. I will now pass it over to Vince to talk about behind the scenes.
Thanks, Dan. Good afternoon, everyone. So I'm Vince Perry from the Army Research Lab, and as Dan mentioned, my team has been developing kind of the capabilities that go into Tyrannics. So as Dan mentioned, there really is those three capabilities on the previous slide with the similar TIR. Thank you. The similar TIRs, the failure definition and scoring criteria reference, and then kind of like a recommended score for the TIRs. So also Dan mentioned that TIRs, while they are very well structured, and there are kind of a lot of features from the TIRs that we have looked into to accomplish some of these, really for the purpose of this talk and predominantly kind of what we focus the most on is that free text portion of the TIR. So that is when whoever is recording the TIR kind of just writes up the description of what happened. So to accomplish that, enter obviously natural language processing, because we have a bunch of free text across hundreds or thousands of TIRs, all written pretty uniquely. So just kind of like as a general natural language processing approach, we really just collect all of that text and do straightforward NLP on it. And some of those are listed there. I'm not going to go through all of them, but what we use behind the scenes is the natural language toolkit. Anyone that's in NLP, this is kind of like a first place to go, just to get the kind of free NLP type techniques that really accomplishes a lot to get your text in a kind of workable form. And then Spacey as well is another kind of common package that is used. So with NLP, right? So the goal here is to get our text in a usable form that we can then run our algorithms against, and then start to compare these TIRs. So the first step we do is the pre-processing. So while we use those packages I just mentioned previously, here's just an example of kind of what that would look like in practice, as a human readable form. So obviously this all kind of happens under the hood, but you have your text there in the top. You do some stop word removal, just removing some very common words, common terms that are probably going to be seen all over the place, things like on and in. And then stemmer lemmatizers, those kind of try to cut words down to really their base form, to stem them, and then you tokenize them. So what it does is it takes separate tokens. In this example, these are words that could be different, and across various different types of text or different corpuses, you might try different approaches. But for this example, you just take each word that becomes its token. And then the question is, right, what do you do with that? Now you have just kind of a bunch of words in all of these TIRs. And our approach is to vectorize that. So essentially here, what we can think about is taking an entire test incident report, all of that narrative text that was written up, and you kind of get it all down to the most basic form of each word that's in there, each relevant word after stop wording. So you kind of have a bunch of words that were attributed to that TIR, and then you throw it in a vector, right? So you vectorize it, that makes it into some matrix, some vector, and then once you do that over every single TIR, you get some matrix, right? Which is just a matrix of a bunch of numbers, which you can kind of see at the bottom. I lost my mouse. I don't even know if they can see the mouse, but you get a bunch of vectors of indicating what words are attributed to that TIR. And really, not that the vectorization process matters a lot. At the top here, you can see kind of the specific ones we use, but really the main focus here is to get to the point where once you have your text in a vector space, in a 3-dimensional or 2-dimensional vector space, then you can compare vectors to one another. So when it comes to TIRs, you just make all the words into numbers. That becomes a vector, and you can reduce the dimensionality of your vectors so that you can get it into really what I like to say is a human understandable type of dimensionality plane, like this 2D plane you see at the bottom here. And then you can just compare, right? So if I lost my mouse again, so similar, right, is when two vectors are very close in nature, versus unrelated would be very kind of across from each other, and then opposite or totally opposite. And this matters for when we're trying to understand, what TIR is, what is in a TIR, and especially with the similar TIRs approach. So that was all centered around the similarity. So similarity scoring for what TIR is similar to other TIRs, so we can return that back to an evaluator. But all of that NLP and background of vectorizing text of the TIRs, that also goes into the scoring recommendation. So now we have a TIR, or we have kind of a bunch of historical TIRs, right, that we have been given that have been scored already, gone through a scoring conference, and they've been scored. So once they have those scores, this is almost like an embarrassingly machine learning driven approach by you just take a bunch of scored data, labeled data, and you train a model against it. And the input to that model becomes this vectorized text. So now we have a bunch of text. Out of each of this text is this scored label. So we train a model against that. So now enter a new TIR that has never been seen before, right? So that model TIR will become input to a model, and then the model output, it will vectorize the text of that new TIR, and then the model output will be a recommended score based off of all of the previously seen TIRs to that. So again, here we're just focusing on the text piece. Keep in mind there are tons of other features of a TIR that very well lean into the actual final scored label of a TIR. So while we have done other feature importance type algorithms to look into what features of a TIR really should be the ones that are included in a model that is trained against this whole corpus of TIRs, for the sake of this, we're really just focusing on a true just the text of the TIR approach. And from just how the TIRs are written, can we produce an output, which in turn is a scored label. So the final capability, so that was 1 and 2. The final one is the reference to the failure definition scoring criteria. As Dan mentioned, this truly is the guide that evaluators have to follow when they are scoring a TIR, right? So it's almost a cheat sheet for us and for algorithms to have, essentially to have the answer presented in front of them. So now given a TIR, you can almost look it up in the FDSC and then figure out what the scored label would be. If it truly was that easy, then we wouldn't need tyrannics. So there are nuances, and all of those nuances come out of text, right? So the FDSC is a full text document. So kind of the same process goes into there with the vectorizing text. That was more of a almost step 1 approach. So as I'm sure is no surprise to anyone, is large language models have been all the rage for the past couple of years. So there's a lot of the approach to large language models that we could glean to utilize. So specifically for this, the RAG process. So if anyone is familiar with large language models, there's an approach, right? So you have a transformer model or just a model that has been already pre-trained. So then you have additional context, right? You have additional data that you want your model to reference. So here, that failure definition and scoring criteria guide can be kind of your additional context that you want to add to a model. And then from that model, it can reference that, right? So that's kind of what's drawn out here. The raw text data, that is the text, and behind the scenes there is a lot of that same vectorization and or embedding techniques, kind of similar concept for this. In that, taking that text, right, taking the text of the FDSC and putting it into some type of knowledge base that your model will reference. So that was our approach taken to the FDSC lookup. A lot of that is solved, excuse me, for us. So this is kind of a work in progress / kind of a future-esque type of concept. So fine tuning. So again, I guess if anyone is not familiar with LLMs, so fine tuning is tuning the weights of a model that exists and tuning those weights to your specific kind of domain, context, use case. But that requires labeled data, right? Well, here we have a bunch of labeled test incident reports. So our approach here was to kind of fine tune a model's weights to learn about the scoring of test incident reports. So our instruction data set really is kind of like already pre-existing historical data that has been labeled. And then we do our fine tuning of those weights based off of those TIRs, so that kind of the output of this model would be, you're given a new model, and then the output is going to be a score for that model based off of what the LLM has learned. But those in each by themselves is great, but really what we're looking for here is this hybrid process, right? So what we would love for to happen at the end goal here would be that we can provide a new TIR, and what will happen is it will return to the evaluator, hey, this TIR probably should be scored like this because from, and then pull from the FDSC because the FDSC says this, and this. And an evaluator can read that and be like, oh, wow, this should be an essential function failure because X, Y, and Z directly out of the FDSC. So this might be a little wishful thinking. That is definitely the direction to head, but that's not where we're at today. Where we really are is 2 slides ago, just in the reference of the FDSC. So here, just a couple of screenshots to really bring to life, hopefully, everything I just said. And so Tyrannics as an application, right? So those were the 3 capabilities that go into Tyrannics as an application. What a user would see is a bunch of TIRs. So each of the rows here would be a test incident report, and the classification of that incident report. So one thing we kind of didn't mention, but so the scoring type, so really an evaluator would be looking to score the preliminary. So in this column, the score type, there you could sort by preliminary, versus scored means that is a historical test incident report that has already been scored, right? So I'm an evaluator. I'm looking to score all these preliminary ones. If it's a preliminary, this classification is also preliminary. So that was given to the TIR at time of writing. It is my job as an evaluator to actually score that TIR. The scored ones versus these, that classification is already a classification, and that is the scored classification. So once you click on a TIR that you would be wanting to evaluate, here comes our recommendation. So you see for the 3 classification types that Dan had mentioned at the beginning, we give our model. So what that does, it passes the text of the TIR to our model, and the model will return what classification label it believes for each of these classifications, and what confidence percentage. So how confident is our model? So again, as it to the user, that this is just a recommendation and a percentage, but not to be taken. Sorry, do you have something?
And last minute.
Yep, last 2 slides. So similar TIRs, same thing, already mentioned it, but you could have similar or similar from previous events. So this would be from already scored TIRs, and this one is just from all the ones that I need to score currently. And then the FDSC guide reference, what that'll provide you back is the section title, the subsection number, and the FDSC guide text.
Okay. Just very quickly, we're looking to deploy this in the data mesh. ATEC also has an online scoring tool that's been on local hardware for some time. That's in the process of being migrated to the data mesh, and Tyrannics should be integrated directly into that. It'll be CAC authenticated, so it will be able to go through all the protocols that the security protocols necessary. Dreaming a little bit bigger, we're looking toward, someday. There's a lot of other data being collected on these systems in addition to the TIRs, so instrumentation data and video and imagery and all those things that could be relevant. We would love to be able to pull those in, correlate them with the TIRs, and do anomaly detection and so forth to get a more holistic picture of the reliability. So with that, I think we will go ahead and stop. Thank you. I appreciate your time.
Thank you.
Thank you. Thank you, Daniel and Vince. Do we have any questions? Anyone in the room have questions for them? Nope. Okay, none here. Anyone online? All right, none seen. All right, thank you very much. We appreciate it.
All right, thank you very much.